Hi, I'm an old guy and I do maths, and today we're going to look at the basics of exponential graphs. And you can see that I've gone to the trouble of actually ruling some lines on a page. And the I suppose that's a hint that I'm going to have to draw something quite carefully. Now, the type of function that we're looking at is an exponential function where x, the value on this axis, this being the x-axis, is an index. And these graphs in this form, just y equals a to the x, no other frills or anything else, have a very, they've got a very particular form. So I'm just going to mark a point on here, and this point is 0, 1. I hope that shows up in the red ink. And what I'm now going to do is graph or draw what looks like, it's often called a hockey stick because of its form. But this is the form that an exponential graph takes, a general form. So if we think about how we get this shape and consider that we're using indices based on the position on the x-axis, this becomes a little easier to understand. So this point here, taking this equation, would be a to the power of 0, because on the x-axis that's 0. And as you know from index laws, anything except 0 to the power of 0 is 1. So in this form, graphs of exponentials pass through 1 on the y-axis. Now, it is possible to move them up and down and side to side and flip them and do all sorts of things with them, but this is the basic shape. And what I'm going to do now is I'm going to take a simple practical example and show you how we come about the coordinates and why this curve takes off and gets very, very steep, and why this part of the curve gets increasingly smooth, and also hopefully point out why in this form this never touches the x-axis, so that the x-axis is in fact an asymptote. And so what I'm going to do is I'm going to take this equation, y equals 2 to the x, because powers of 2 are easy to do. And we'll start at negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4. This may take you back to earlier times at high school. We're basically going to put these values of x into this equation and come up with some numbers. So let's start with the one that I started with. So 2 to the power of 0 is 1. That's our y value, 1. So that's how we get this point. 2 to the power of 1 is 2. 2 to the power of 2 is 4. 2 to the power of 3 is 8. And 2 to the power of 4 is 16. These numbers are getting increasingly larger, and they're doing so at an exponential rate, hence exponential graphs. This thing is often referred to, certainly from here on, it's often referred to as an acceleration curve, because it gets faster and faster and faster for the physicists amongst you. Okay, so that explains why these points would suddenly accelerate in this direction. So if 1 is here, that might be 2. If 2 is here, that would be 4. If 3 is here, we're already at 8. And it's not 14, it's 16. Oh dear. And 4 out here would put us at 16 up here somewhere. I apologize for that. Okay, so let's go in the other direction. Well, 2 to the negative 1 is a half. 2 to the negative 2 is a quarter. 2 to the negative 3 is an eighth. And 2 to the negative 4 is not a 14th, it is a 16th. Dear me. Okay, so what you can see is that as we move along the negative x-axis, that we start at a half, say somewhere around here. Our next y value is a quarter, then an eighth, then a 16th, and so forth and so on. And hopefully what you can understand from this is that as this number moves further and further and further along the negative side of the x-axis, the fractions get smaller and smaller and smaller and smaller, but this thing never touches 0 in this form. And as I say, we're just dealing with the basics here. Right. So what else can we say? Well, we can say, therefore, if I haven't said it already, I think I did, that the x-axis here is an asymptote. And as I said, all exponential functions in this form, y equals positive a to the x, they all look like this and pass through 1. But they are capable of being played around with just like any other graph is. We can move them up and down, we can move them side to side, we can dilate them, anything that you can do with other graphs you can do with these. But this is really just the basics of it. And I hope that explains a few things and gives you a decent grounding in what these things look like and why. Thanks very much for watching. See you next time.